I forgot I was going that long.
This is 4.7, part 2. Now on the unit circle, try and find the sine inverse of 2. Where on the unit circle do you find the y value to be 2? You don't. Think about the unit circle. The y values are on the entire unit circle. It has a radius of 1. So this is outside the restrictions that we had. The restrictions have to go with the domain. This has to fall between -1 and 1. Does it? No. So this does not exist. So it's not possible to find the sine inverse of 2. All right. I'm not going to go as in depth now with the cosine inverse and where all the ordered pairs come from and such. So if you want to go ahead and write this slide down. The cosine inverse can be rewritten as also arc cosine. So you'll see it written both ways. You have to be comfortable with both ways they write it. Notice the range is a little bit different. The restrictions on the domain are still the same as the sine function, the sine inverse function. It's -1 to 1. But now my range of angles are going to only happen in the first and the second quadrant. So to review the cosine function, you don't need to graph the cosine function. We are only going to focus on the region from 0 to pi and inverse that. So what it looks like as a graph, y equals the cosine inverse of x. If here's -1 and 1, here's 0 degrees, here's pi over 2, and here's pi. If we were to graph the cosine inverse, it's going to also just have a region, and the points would be like this. I'm just graphing 3 of them, just a quick piece of it. It'll look like that. Oops. And then we'll do some evaluation with our unit circle on the next examples. So again, how you find the cosine inverse is you interchange the ordered pairs of the x and the y.
Are you supposed to be like lines and arrows?
Something like a little swiggle, kind of. Okay, so these will get easier now that we've done the sine inverse. Remember, on the unit circle, this is the x of the ordered pair. On the unit circle. What we want out as an answer is an angle. So if we think about the unit circle, there's 2 places on the unit circle that you get a -1/2 for your x ordered pair. Where on the unit circle will it exist?
2, 4, 5.
4 pi over 3?
2 pi over 3.
2 pi over 3? 2 pi over 3?
Right
yet we're talking the x value. Do we agree? The ordered pair here is negative 1/2, and then the square root of 3 over 2. Where is the other place at? 4 pi over 3. Do we care about this one down here? No, we don't care about this one because it's outside our range. We only want angles that fall between 0 and pi now. Remember, this is our cosine, this is our sine. So our answer then is 2 pi over 3. So maybe this next example you just want to listen and watch and help me out. All right, cosine inverse of square root of 3 over 2. Where is that? Pi over 6? Do we agree? Pi over 6? Remember, there's another place. So this ordered pair is square root of 3 over 2, and then 1/2. We're looking at the cosine. So the angle is pi over 6. Last one, don't need to write it down. Cosine inverse of 5. Can't exist, right? It's outside our domain. Our domain has to fall between negative 1 and 1. So this doesn't exist. All right, our last trig inverse is tangent. So tangent inverse or arctangent are the same equation. The restriction now on the domain is nothing. Because I think about graphing those tangent functions. Those tangent functions, they were like snakes, and they had asymptotes to help guide those snakes. When we flip-flop the x and the y values, my x values now are going to go on forever. And you'll see the difference between when I graph the two. So the domain for the tangent is all real numbers. Now the range is the same as the sine inverse function. And the difficult part with tangent inverse, as is tangent of a function, is they're not shown on the unit circle as ordered pairs. How do you find the tangent of something? Sine over cosine. So it might be a good idea to take your unit circle, go around the entire unit circle, and evaluate the function every single time around and find out what is the sine over the cosine of each of those places. Because this is the ordered pair y over x. They're going to be the hardest of the three. Okay, so to review with you what the tangent parent function is, here's negative pi over 2, here's pi over 2. Let's graph the asymptotes. And then over the halfway point looked like this, and then I had it snake. If I interchange those ordered pairs, all those vertical asymptotes now are going to be horizontal asymptotes as an inverse function. So here's pi over 2. Here's negative pi over 2. They're going to be horizontal asymptotes. And then imagine this snake inversing. What it's going to look like still has that halfway point, but now my snake looks like this. Remember, each of these inverse functions can be reflected above the line y equals x. Now we have some examples on the next slide.